guys, welcome to our YouTube channel once again. Welcome to Add Maths plus Maths. Today we will be discussing derivatives of exponential function. And one thing that you need to understand about derivatives is it's always related to the first principle, wherein first principle is always a small increment of y over a small increment of x. It means, and you need to remember that when a point moves from its stationary point, not really a stationary point, from a point going to another point, there is always an increment from this x, an increment of x going to the next point. And if there is an increment of x going to the next point, there is also an increment in y. Okay? So if I have a function y is equal to e power of x, remember, x here is an exponent or an index. Okay? So there will be a change in the equation will be y plus increment of y is equal to e to the power of x plus increment of x. So, because there's a change in the y and the x. Okay? And remember guys, from your laws of indices, okay, a power of m plus n, okay, is equivalent to a power of m times a power of n. Thus, e power of x plus increment of x will be e power of x times e power of increment of x. Okay? Now, I want to come out with increment of y over increment of x over here. Okay? So I need to remove y and move it to the left side. So I will be subtracting y to both sides. Okay? And then remember that y is equivalent to e power of x. And if y is equivalent to e power of x, I can change this to e power of x. Okay? And take a look at this. There are two terms over here. E power of x times e power of increment of x. Okay? And e power of x. Negative e power of x. What is common to both the terms? Okay? It is e power of x. So I can bring out the e power of x. Okay? Factorize it out, and inside the bracket will be e increment of x minus 1. Okay? Now, as I've told you a while ago, I want to come up with increment of y over increment of x because we are using the first principle. So I need to divide both sides by increment of x. Okay? So therefore, increment of y over increment of x is equal now to e power of x times the quantity of e to the power of increment of x minus 1 over increment of x. Thus, if we are trying to recall from the first principles, okay, remember that the derivative of y in terms of x is equivalent to the limit of the increment of y over increment of x as x approaches 0. Okay? Now, examine what will happen to this as x approaches 0. Okay? We'll have a table. So it is 0.02 and then 1.10 for the value of the increment of y over increment of x. Okay? Next. Okay? Okay? What do you notice? As increment of x approaches 0, the increment of y over increment of x, okay, will be going near and near and near to 1. Okay? Thus, the increment of y over increment of x is going nearer to 1. Okay, and 1 times e power of x, 1 times, remember a while ago, increment of y over increment of x is e power of x times this one. Okay, so 1 times e power of x will be e power of x. But remember, dy over dx is equivalent to that. What will happen if the index will not be only x? What you will do here is get the derivative of the index, then you multiply it with the original function. Example, e power of 5x. I will write first, I will be using a cover up chain rule over here. Okay, I'll cover up that index, which is 5x. Okay, I'll write the original function. Okay, and then ask myself, what is the derivative of 5x, or differentiate 5x? It will be 5. That 5 will be multiplied to the original function. Thus, the derivative of e power of 5x is 5e to the power of 5x. Okay, I hope I made myself clear. Letter B. Still cover up chain rule. We cover up that index, which is x squared minus 3x. After that, we write the original function. And then take the derivative of x squared minus 3x. What is the derivative of x squared minus 3x? It is 2x minus 3. And then you multiply it with the original function. Thus, the derivative of e power of x squared minus 3x is 2x minus 3 times e, or the quantity of 2x minus 3 times e to the power of x squared minus 3x. Okay, as simple as that. So write the original function, get the derivative of the index, then multiply it with the original function. That's already the derivative of letter B. Okay? Next, for the letter C and letter D, I'll be moving you with the whiteboard so that I could better explain the working of this one. Okay? So we are now in the whiteboard. Okay. Letter C is x squared times e power of 3x. So if you notice, it is x squared times e power of 3x. So it means, okay, I am basically multiplying two factors. So since I am multiplying x squared and e power of negative 3x, okay, I'll be using product rule. And when I am using product rule, I have to know to let u is equal to the first factor, which is x squared, and I have to let v is equivalent to the second factor, which is negative 3x. Okay, and you know that when we say product rule, you have to find out the du over dx, which is 2x, and the dv over dx, which is negative 3 e power of negative 3x. How did I know again it's negative 3 e power of negative 3x? What is the derivative of negative 3x? Negative 3. Then put in the original function. What did I use? I used cover up chain rule method. Okay? Next, to find out d over dx of u times v, you have to get the u, multiply it with the derivative of v, then add it with v times derivative of u. Just a little bit of recall, okay, so that you will be guided. So it means the derivative of this thing okay, is equivalent to u is x squared. Okay, dv is this one, so times negative 3 e power of negative 3x plus, okay, v, which is e power of negative 3x, multiplied it with du, which is 2x. Okay, this will be a negative term, so I'll just put it on the next term, so it will become negative 3x squared e power of negative 3x. Okay, then bring this in front. Okay, it doesn't matter if even if I put that first, but okay, it will be better if the first term should not be a uh, negative term. Okay, then e power of negative 3x. So this is now the derivative. If you want, you can factorize out e power of negative 3x, then multiplied by the quantity of 2x minus 3x squared. Or you can factorize out e power of negative 3x times x, then multiplied by 2, okay, minus 3x. Okay, but you can leave your answer like this. Okay, let's move on to our letter D. Letter D, you will notice that it is e power of 2x divided by x. So when I say divided by, so it means it's a quotient of two functions. Okay? And please recall that when we talk about quotient of two functions, we are dealing with quotient, or we are going to apply quotient rule. Okay? So I have e power of 2x over x. And quotient rule, just to recall again, is low d high minus high d low over low low, so that you can uh, just memorize. Okay, so it means this one, let u is equal to e power of 2x, let v is equal to x, du over dx, or the derivative of the one on top, or d high, will be equivalent to 2 e power of 2x. D low is dv over dx, which is equivalent to 1. Low is x, d high is 2 e power of 2x, minus high is e power of 2x, d low is 1, over the lower portion multiplied by itself is x squared. Okay, factorize out the common monomial factor between these two, which is e power of 2x. 2 times x is 2x, minus, you divide that, it will become 1 over x squared. So your final answer will be this one. Okay, that is letter D. Let's move on to our letter, the next example. Okay, which is this one. So a curve has equation y is equal to e power of 2x plus e power of 3x, okay, to the power of 5. Okay. You will notice that it is a function inside the bracket with an index. Okay, is it familiar? So this rule is what you call chain rule. Okay, so basically you have to do cover up chain rule, but there's something written in here: find the value of dy over dx when x is equal to 0. So after finding the value of dy over dx, or the derivative of y in terms of x, change all the values of x to 0 to find out the value of dy over dx. Okay, so cover up chain rule, cover that up inside the bracket, put that 5 in front, then subtract with 1, it will become power of 4, this one. Then get the derivative of the one inside the bracket, which is 2 e power of 2x, and plus 3e power of 3x. Next is to change the values of x to 0. Okay, so if that will become 0, e power of 0, e power of 0, e power of 0, e power of 0. Why all power of 0? Because 2 times 0 is 0, 3 times 0 is 0. And remember, any number raised to 0 is equivalent to 1. So 1, 1, 1, 1. So 1 plus 1 is 2, 2 to the power 4 is 16. 2 times 1 is 2, 3 times 1 is 3, 2 plus 3 is 5. So 5 times 16 times 5 is equivalent to 400. That ends my lesson. Thank you very much for watching this video. I hope you have learned something. Please don't forget to like and share. Thank you for all the support that I am receiving for this YouTube channel. Those who haven't subscribed yet and it's your first time to watch my videos, please subscribe and click that bell button so that you will be updated with our new lesson videos in mathematics and additional mathematics.